Alright, here we go. This video is special products. So it kind of goes off the topic of multiplying polynomials, but these are called special products because there are some shortcuts to them. So we're going to talk about perfect square trinomials, and I'll get to what those are. One's with positive signs, one's with negative signs. So those are the first two things that we're going to talk about. And then difference of perfect squares. That's the third type of special product that we're going to talk about. So the first two are kind of go hand in hand. One just has positive signs, one just has negative signs. And three, difference of perfect squares. That'll actually deal with one positive and one negative. So a trinomial of the form a squared plus 2ab plus b squared is called a perfect square trinomial. A perfect square trinomial is a trinomial that is the result of squaring a binomial. So what you're going to see is some binomial, okay, in this case let's just do a plus b. So some a term plus some b term, and it's going to be squared, or you might see it as a plus b times a plus b. Okay, now I'm actually going to go like this, and I'm going to FOIL that out, and we're going to see what happens. So a times a, that gives me a squared. A times b gives me ab. B times a, that gives me, well, ba, or another ab. And then b times b gives me b squared. And then you can actually add the ab terms together. Imagine there's a 1 in front of them. So that's going to give me a squared plus 2ab plus b squared. Okay, so that's where that little formula comes from. It is when you're taking a binomial and you're just squaring it, or you're just taking it times itself. So there's a little short that we can do, and we're going to use this little setup. So basically what you do is just square the first term. You take 2 times the first times the second, and then you square the second term. So what I'm going to do to kind of help us out is make kind of a picture here. So we got the first term, and then we're going to square it. So we'll make like a little bubble here or something. You're going to add 2 times the, well, I'll just make little circles, times the first times the second. And then you're going to add the last second term squared. Now you might know, this might seem a little weird at first, but once you get the hang of it, it actually is quite a nice shortcut. So what I'm going to do is I'm going to copy this, and we are going to go look at some problems. Here we go. Put that up in the corner there. Move this guy down a little bit. Okay, so finding products in the form a plus b squared, or just a plus b times a plus b. They mean the same thing. Okay, so if you notice letter A, we have x plus 4 squared. So what my first term is the x, my second term is the 4. That's the only thing I really even need to worry about. And you're going to follow the setup. You're going to take the first one squared, so just x squared. And then we're going to add 2 times the first times the second. So what that is, do a little scratch work up here, 2 times x times 4. And you can combine the 2 and the 4 together. So that gives me an 8x. Okay, so following along here, we got that. And then we're going to add the second one squared. So plus 4 squared, that's going to give me a 16. Okay, so you square the first, 2 times the first times the second, and you square the second. So following along with this, again, square the first, so that gives me x squared. 2 times the first times second, so 2 times x times 6. That'll give me a 12x. And then this one squared, the second one squared, that's going to give me a 36. There's my answer for that one. So just a few more of these. A little bit more complicated problems. Let me paste that little setup right here again. Put that up there. You can use those little bubbles if you want, but if you don't feel like using them, that's okay. So again, square the first. Now this is going to be tricky. 5a, make sure to, when you square that, you got to square the 5 and the a. So that's going to give me a 25a squared. So it's kind of like 5a times 5a. Okay, now 2 times the first times the second, so 2 times 5a times b. Now the 2 and the 5 will give me 10, and the a times b will just give me ab. And the last one squared, the b, that's just going to be b squared. Okay, letter b here, square the first, so 3x times 3x, that'll give me 9x squared. 2 times the first times the second, so 2 times 3x times 2y, so 2 times 3 times 2, that'll give me 12, and then just xy, and then square the second, so 2y squared, 2y times 2y will give me 4y squared. We'll do one more of the perfect square trinomials with the adding. So again, we have the first and the second, so the first squared is still 1. And then 2 times the first times the second. So that's just going to give me a 2c to the third. And then the last one squared, so c to the third times c to the third should give me a c to the sixth. Okay, so that is that one. So remember, when you're multiplying those, make sure to add those powers, 3 plus 3. Okay, so moving on to a trinomial of the form a squared minus 2ab plus b squared. So that is also a perfect square trinomial, except in that form, it's when the middle sign is negative. So before we had a plus b, now here's the shortcut for something that's a minus b, or when there's just a negative in the middle, as you can see with these two. So anyway, it's going to be the same kind of setup, but only with a negative in front of the 2. So I'll make my little bubbles here again. So the first one, squared, minus 2 times the first times the second. Now the way that this is set up, you actually don't need to worry about the sign being with the number. So we're just going to kind of forget the sign altogether. And then plus the second one, squared. So the same thing we've been doing. Again, what's my first term? What's my second term? X and 5. So we don't need to say it's a negative 5, it's just a 5. So we're going to square the first. That gives me x squared. Minus 2 times the first times the second. So negative 2 times x times 5, that's going to give me a negative 10x. And the second one squared, so 5 squared, will give me a positive 25. Okay, there's my answer for that one. And remember, in all these problems, if you ever are unsure about your shortcut, you can always FOIL it out. Again, that's saying x minus 5 times x minus 5. So if you wanted to, you could FOIL it out if you really wanted to. Otherwise, these are shortcuts. These are a shorter way to do it. Next one here, x minus 7 squared. So the first one squared, so x squared, minus 2 times the x times the 7. So that gives me negative 14x. And then plus 49. So that's the answer for that one. So a few more problems like this. Square the first, so that's going to give me 36. A squared, 6a times 6a. 2 times 6a times a 1 will give me a negative 12a. Or sorry, negative 2 times 6a times 1. And then 1 squared will give me a plus 1 on the end. Next one here, 3b squared. So 3b times 3b will give me 9b squared. Negative 2 times 3b times 2c. That'll give me negative 6, negative 12 bc. And then 2c squared. So 2c times 2c will give me 4c squared. And that is your answer for that one. All right. So going on to the last type of problem, this is what's called a difference of perfect squares. So it's when you have a term times almost the same term, but the only difference is that one is positive, one is negative. So you notice in letter A, I got one positive, one negative. And here we got one positive, one negative. So when you're going through the homework, make sure to look at the problem and make sure to use the right shortcut. So this one's kind of an altogether different setup. It's just a squared minus b squared. So basically, it's just the first term, and you square it, and you subtract the second one, and you square it. So this one's actually pretty easy. So for letter A, what's the first term in each? So it's x, so you got to square that. So that's x squared. The second term is 6 in each. So minus, it's always going to be minus. And then when you square the 6's, it's going to give me 36. Okay, so why are these so simple, and why is there only 2 terms for these? Well, if you FOILed this one out, so this is just kind of a side note, if we're going to do it the longer way, x plus 6 times x minus 6, we FOIL that out, we got x squared plus 6x minus 6x minus 36. And what's always going to happen with these difference of perfect squares is that we're going to get 2 identical terms, one of them positive, one of them negative. So those are going to cross out always. And we're just going to be left with whatever the first one is squared and whatever the last one is squared. All right, so this only works for these kinds. So x plus 8 times x minus 8, square the first, so x squared, and square the second, so minus 64. There you go. Don't overthink it. A few more. So we got 7 plus n and 7 minus n. Remember, the only difference is that one's positive, one's negative. So 7 squared will give me 49. Minus, and n times n will give me n squared. Now, it doesn't matter if the positive one is first and the negative one is second. It'll still work the same way. So if these were flip-flopped around, it would still work. Letter B here, so square the first. So squaring an x squared. So think of that as x squared times x squared. That's going to give me x to the fourth. And 2y squared, that's going to give me a 4y to the second. So 2y times 2y will give me 4y squared.